Hi, and welcome. Today we'll be exploring the kinetic connection, how physics isn't just an abstract theory, but an essential part of diagnosing and treating animals. From every step to every leap, there's a measurable force at play. In the next 10 minutes, we'll cover how veterinary medicine uses physics, especially mechanics, motion, and energy. We'll look at how Newton's laws apply to animal movement and healing, and examine real applications in diagnostics, rehabilitation, and prosthetics. Alright, so basic physics principles such as kinetics and kinematics are essential in analyzing animal movement. By applying these principles, veterinarians can better diagnose injuries, understand their causes, and implement preventive measures to ensure optimal animal health. Because animals can tell us how and what hurts, but physics gives us this language of force, energy, and motion that reveals what's happening beneath the surface. So, whether a dog limps or a horse stumbles, physics makes those patterns measurable and diagnosable. Newton's three laws are the foundation of animal movement: a dog sprinting, a cat leaping, or a horse halting. Each of these is governed by forces and motions. Vets rely on these principles when assessing abnormalities in motion. For Newton's first law, animals stay still or move unless a force changes that. For his second law, force needed depends on mass and desired speed, right? And finally, his third law, ground pushes back during steps, so force is bidirectional. Newtonian analysis in the clinic. If you watch how a dog lands after jumping, if one side receives less force, that's a sign. It may indicate pain avoidance or instability. And understanding how force travels lets us pinpoint the problem and reduce future injury. The musculoskeletal system constantly manages four types of force: compression from weight, tension from muscle pull, shear from sideways movements, and torque during turns. Each one matters in injury diagnosis or designing braces and support. Okay, and this is just an extra image that shows us compression and tension. Okay, biomechanical gait analysis. So, gait analysis has become a clinical standard. Pressure sensing treadmills and motion capture tools that give a full breakdown of how an animal moves. We can see where force is uneven or if one leg is compensating for another, which is a clear sign of dysfunction. Gait analysis in practice. So this is first one here is an example of a visual pain scale. Typically, a 10 centimeter line is used to show how much pain or lameness an animal has, with one meaning no pain or lameness, and the other end meaning like not using the leg at all. Typically, an X is placed on the line to show how bad it is. This is then added to the medical record and can be used later to check if the animal is improving or getting worse. Figure 2 right here shows us reflective markers that are placed on a dog, and as this dog moves, the cameras track the markers. This data is then used to create a 2D or 3D model of the dog's movements, showing how its bones and joints move. Figure 3 and 4 measure the forces between the dog's paws and the ground when they walk. The most common way to do this is with force plates, which are metal plates in the floor that measure pressure. These plates mainly record vertical forces like up and down, which are usually stronger than side to side or forward backward forces. Hydrotherapy has become a favorite rehab method. Thanks to Archimedes' principle, when a dog walks in water, buoyant force lifts some of its weight. That means our arthritic or post-op joints carry less load, easing joint pressure, and at the same time, drag resistance challenges muscles, which is ideal for injured or aging pets. Okay, and this is just a table of the application in hydrotherapy tanks. I provided variables with suggested by and the effects. Buoyant force in water therapy. So let's suppose a 30-kilogram dog submerges halfway in the water during hydrotherapy, and we need to estimate the buoyant force. So assuming that half of the dog's volume is submerged at 0.015, we use the formula buoyant force equals density times volume times gravity. And we get 1000 times 0.015 times 9.8, which equals 147 newtons. So this buoyant force means that the dog effectively weighs less in water, reducing joint stress while still allowing controlled movement. And this principle is the foundation of hydrotherapy. And as we explore hydrotherapy further, we move beyond buoyancy and look at the drag force, or water resistance, which is a critical force that animals encounter during movement in water. It is said that water is about 800 times denser than air, so any movement in it naturally faces resistance. And this is where drag comes in. It slows down motion, but importantly, it also provides gentle resistance, which this resistance acts like a natural weight training for recovering animals, allowing them to rebuild muscle, coordination, and balance without the high impact stress of land-based exercise. This principle allows therapists to customize resistance simply by adjusting speed or water turbulence. In this specific example, the dog's limb encounter about 10.8 newtons of resistance during each stroke. This resistance builds strength and coordination gently, ideal for post-op or arthritic animals. When animals lose a limb or function, prosthetics step in. These aren't just accessories, they're biomechanical tools. Designers must consider torque, limb length, and energy absorption and materials that flex like muscles. Um, as we know, prosthetics must do more than just fit. They must move right and reflect the forces acting on joint and limbs. For example, if a cat's center of mass, gait rhythm, and force flow all guide the design. And the goal is not only to support motion, but to restore natural propulsion and gait rhythm using biomechanical modeling. For this case study that I provided here, we have a domestic short-haired orange tabby with a rear limb amputation. And its diagnosis was an increased spinal torque and unbalanced argument, so we can assume that he or she twisted their spine, compensating for the missing limb. When a veterinarian analyzes these forces profiles from a gait study, they use the data to design could be a carbon fiber prosthetic that realigned their body mechanics, and resulting in a more fluid gait, enhanced endurance, and significantly reduced strain. Thermography and force mapping and diagnostics. So pain is invisible, but it changes physics. When an animal is in pain, energy escapes as heat. Thermo, thermogra- sorry, Thermography captures this, making a non-invasive tool to detect inflammation early and help detect and treat issues before they become major injuries. So In conclusion, physics isn't just theoretical, it directly supports veterinary practice. And understanding the importance of animal movement and the role of basic physics in veterinary care is critical. This knowledge helps in accurate diagnosis, effective treatment, and injury prevention, ensuring the well being of animals. Alrighty, so thank you for joining me on this exploration of veterinary physics. The kinetic connection shows us that movement is more than motion, it's healing, diagnosis, and hope.